All right, yeah, so essentially we look at our little chart, and again, sometimes you can use the chart, you'll be like, oh, there is no even secant, so I can't use that one, and then you'll go to the odd or the odd tangent, and it does end up working out. But sometimes it doesn't, so just because you're following these charts doesn't necessarily mean that that's going to be the one that you use. I don't know if the video cut out when I mentioned that whole thing about that meme that I sent you guys about how confusing it can be, but essentially just start with somewhere that you know, and if it doesn't work, don't freak out. Doesn't mean you're doing it wrong. It just means that you have to approach it a different way, okay? But this one worked out. We do have an odd tangent, sorry. So we will let u be equal to secant theta. We take the derivative of that, we go back to our chart, and we get secant tangent d theta. And then from this information right here, we know that tangent squared is equal to secant squared minus 1. In this case, I have rewritten it. I will show you why I've rewritten it in a second. I've just added that 1 to the other side, okay? So, I'm going to go ahead and start replacing this stuff with our theta. So remember, our goal is to have that du at the end of our problem. So we need one secant and tangent by itself. So I'm going to take away one tangent from here, which would leave 4 tangents. But because we're working with these squareds, I'm going to write it as tangent squared squared, okay? So we have tangent squared squared, then we have that leftover tangent and the secant and the d theta, okay? So now this brown part right here, we're ready to replace it as our du. And then this tangent squared, we're able to replace it as, oh, actually I didn't have to rewrite that. Maybe I thought I was gonna have to do that, and I don't know, maybe I was working too fast, okay? Sorry, so you didn't actually have to change that up. You could have just plugged it straight in. We know that tangent squared is equal to secant squared minus 1. I don't know why I did that. Okay, cool, so we rewrite that as secant squared theta minus 1. And the reason why we're changing it to secant is because we're about to change all of our thetas, the entire thing from thetas to u, and our u is equal to secant, okay? So now, when we do that, we know that secant is now u from this, so we're going to have u squared minus 1, and this is all being squared, and then this brown part is our du, okay? We have it squared, which means to FOIL it. When we FOIL, we get this, and then we just take the regular integral, add 1, divide by that number, add 1, divide by that number. When you just have a number, it's just the variable. Okay, we have that 4 square root of 2 on the outside. So whenever you're, oh, well, we're not evaluating it. So yeah, essentially, we were not originally given u, we were given x. So now we have to reverse everything that we've done. So we'll start with the u, and we'll go from u to theta, and then we'll go from theta to x, okay? So we're gonna just reverse that, all right? So we know that u is equal to secant theta, so that's what we're gonna do first. All of our u's are gonna become secant thetas, okay? And then we add the plus c because we're not evaluating it from anything. Uh-oh, about to sneeze. No, I'm not. Okay, whew. Okay, so then from here, we need to figure out how to change our theta to x's. And from our first part, we know that x is equal to the square root of 2 tangent theta, okay? So that's what this green part is. This green part right here is trig stuff, okay? So whenever you see this green stuff, it's either trig related or college algebra related, and I'll write that in green, okay? So essentially this goes back to our triangle. We solve for our theta, we solve for our trig function, so we have to divide both sides by the square root of 2. So tangent theta is equal to x over the square root of 2. You need to remember SOHCAHTOA whenever you're trying to find thetas. TOA would be our tangent, that's opposite over adjacent. So that means our opposite is x and our adjacent is the square root of 2. So we draw a triangle, we pick a theta, and then remember, opposite is going to be the one directly across from here. Adjacent is the one right next to your theta. And then hypotenuse is always the slanted one, right? Okay, so We've identified our O and our A, and then we use the Pythagorean theorem to figure out our other side. Okay? Once we do that, we're able to figure out what secant is. So secant is the inverse of cosine, right? So that's 1 over cosine. And cosine is A over H from SOHCAHTOA. So essentially we're looking for H over A, okay? So our H is the square root of x squared plus 2, and our A we already knew was the square root of 2, okay? So this is our new secant theta. So all we're going to do is take this problem right here, and instead of the red secant, we are now going to write our new secant in terms of x, okay? And then once you do that, you just do a bunch of simplifying, and then you'll get your final answer.